Hello. On worksheet 3, 6 through 10, I have 5 resistors that are not these values. I want you to use the first 5 in the worksheet. And then do calculations for current and power and see if they're safe to build at 2 different voltage levels, which are different from what I'm showing here, because I want you to work through this and not just repeat what I'm doing. I want you to gain some understanding. I'm doing it in Excel. You could do it in Scilab. You could do it on a calculator, but hopefully you'll see the value of doing it in Excel. This is a very simple circuit, and I've got it up in Spice in the background here. Here's my voltage source. Here's my first resistance, if you will. I can do my dot op analysis on it and get the current that way, or I can realize that since it is such a simple circuit, I can get the current by taking the voltage of the circuit and dividing by the resistance of the circuit. And so I want you to find the current for 12 volts. And these are my Ohm's law equations, and these are my power formulas, which are often associated with Ohm's law, but they're not truly Ohm's law, they're just power. Anytime you go to build a circuit in the lab, our current is limited to 1/4 watt, which would be 0.25 watts. So we have to be below that, and this is the designation as to whether it's safe to build. Some of our smaller resistors are 1/8 watt, and they would be half that, or 0.125 watts. And if I put a 0 in there, it'll look better. There we go. Anyway, okay, so if I have a 12 volt current source, 270K of resistance, then my current, which is what I want in this column here, is equal to 12 divided by 270. Excel does not recognize engineering prefixes, so you've got to remember to convert them. So that would be my current for that first resistor. It's a very, very small current, and I can do the same thing all the way down, or I can well, I'll have to do the same thing all the way down because I don't have these converted. So to find the next current, I would have to type in the same thing. One of the things I want to show you, though, is if I go over here and I change my 270K to 270,000, enter, 1.1K, I'm going to change it to, that's 1100. 33K would be 33,000. 680K would just be add 3 zeros, and 69K would be add 3 zeros. Now what I can do is I can go in and I can take my 12 that I'm giving you and I can divide by 27,000, or I can refer back to the cell. So I'll get the same answer as if I type in B2. So column B, row 2, refers back to, oops, I do want A2. I want to refer to this column and row. And anytime you type an A2 in Excel, it will pull whatever number you got in that space into your equation. And what you see is I got the same answer. This helps me now because now I can copy and paste this formula all the way down. So if I click and do a copy, and then I click and hold and drag and highlight all those cells, and I like to use the Control V shortcut, I can paste, and those are all my currents. And this is a fast way to do all the solutions. Power involves these currents. Now, there's 3 different formulas typically used. This bottom one here that I highlighted is for DC only. So as long as it's not an AC voltage or an AC current, you can use VI. In this case, it's all DC. It's a 12 volt DC, and our current is DC. So my power, I can just multiply my voltage times my current. So for the first one, I can go in and say, okay, it's equal to B2, 12 would be my voltage, times the shift 8, B2. So I can take the cell where I did a calculation and use it in another calculation. So there's my power. Then again, I'm going to copy and paste these down. And I can right mouse click to paste too. I don't have to use the shortcuts. And there's all my powers. Now what I need to do is see how they compare to these readings here. If I'm a 1/4 watt resistance, and I think that's what I asked for in the worksheet, is this number less than that number? If so, it's safe to build, so that would be a yes. And if you want to spread things out, usually there's a way you can spread out what's in the column. Of course, it messed that up, but that's okay. So this is less than that, so it's still safe to build. And I can even copy and paste this down if I want to. If they're all safe, I can just go on down. Control V. Now what I'm going to do is I'm going to change my current, but my voltage, but use the same resistance. Okay. So what you're going to see is same process. I'm going to find the current by taking 120 and divide it by this A2. So equals 120 divided by A2. And that gives me my current if I put it in a 120 volt circuit. So in Spice, I would have to go in and change this to 120, and to do each individual resistance, you'd have to go in and change the resistor. Then you'd have to do the DC analysis. You could get the answers that way. It would give you good Spice practice. But sometimes you want to even be more efficient than that. So I've got my current for the 120. I'm going to copy. I'm going to get all my currents, paste, there's all my currents, and do you remember how we did the power from before? Take my voltage, equals 120 times, and the current would be E2 in this case. And so then once I have that one, I can copy and paste down. Alright, one thing you notice is now I go back and compare to my 250 here. This one's safe, this one's safe, this one's not, this one's not, but this one is. So I have 2 yeses, 1 yes, 2 no's, and 2 yeses. And if I want to center it, I can center it, make it look good. So this is what I'm looking for in the chart for that worksheet. Now, obviously you can round these currents, you can round these powers, you can add engineering notation. Generally speaking, the current, you'll put up in here in the top that it's in amps. And then you don't have to make sure you get the unit. But if you do go to an engineering unit for one but not the other, then you've got to put the current in the box down below. But this is how to work on 6 through 10. And thanks for watching.